Okay, guys. Picking up from last week. Last week, if you remember, we left off at finding the mass of 1 mole of a substance. And remember, we said that in order to find the mass of 1 mole of a substance, what we have to find is the relative molecular mass, the RMM, or sometimes it's also called the molar mass. And I had left you guys with these 4 questions that I asked you to figure out the relative molecular masses of. So if we just quickly go through maybe just the first or 1 or 2 of them. You had C6H5O6, and remember what you're doing to find the relative molecular mass is you're adding up the masses of each element, the relative atomic masses for each element in their respective amounts. Where do you get these relative atomic masses? These are the mass number of each element from the periodic table. So for this compound right here, C6H12O6, that's glucose, okay? And it consists of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So the relative atomic mass for carbon is 12. The relative atomic mass for hydrogen is 1. And the relative atomic mass for oxygen is 16. So that's going to be 6 multiplied by 12, which is 72, plus 12 times 1 is 12, and then 6 multiplied by 16 is 96. And then all you have to do is sum all of that up. So 72 plus 12 plus 96. And that's 180. And remember, this is your unit. Unit is grams per mole. This is telling you that this is the mass of 1 mole of glucose. All right. And remember, 1 mole of anything contains the Avogadro's number of particles. So if you have 1 mole of glucose, there are going to be 6.0 times 10 to the 23 glucose molecules in there. And all those glucose molecules together will have a mass of 180 grams. Let me just do one more just to make sure I recap sufficiently. And if we have here sodium sulfate, if we want to find the RMM of sodium sulfate, we're going to multiply the mass of sodium by 2 because there are 2 sodium atoms in the compound, plus the mass of sulfur, plus 4 times the mass of oxygen. So remember, you don't have to sit and study the periodic table. You don't have to sit and study the mass numbers for the atoms because those relative atomic masses will be given to you in your exam. If you know them, and some of them you will know them, it will make it easier for you. It will make it quick. You can move through the questions quicker because you won't have to be searching for the masses, but you will get the masses. Okay? So the mass of sodium is 23. So it's going to be 2 multiplied by 23. The mass of sulfur is 32. And then oxygen has a mass of 16. So 4 times 16. 2 times 32 is 46 plus 32. And 4 times 16 is 64. So 46 plus 32 plus 64, 142. Again, your units are grams per mole. Sometimes you'll see mole abbreviated MOL. I don't really see the difference between just dropping the E, but that's the way you'll see mole abbreviated sometimes. So sometimes instead of seeing it as grams per mole, MOLE, you'll just see grams per mole, MOL. All right? Again, as you read and go through your text, just something that you may pick up and be curious about. Okay? I'm going to do one more with you, which is something that may look somewhat complicated, but it is not. Once you follow the same principle, you will never go wrong in terms of finding out relative atomic mass. We're going to look at a more complex example. What's the RMM of hydrated copper sulfate? I remember hydrated copper sulfate has those nice pretty blue, well, is that nice pretty blue crystal. And the structure of the compound, or the formula for the compound, is this, where we have these water molecules in the structure, these water of crystallization molecules. So if you're given something like this in a test, you're also going to get the relative atomic masses. So copper is 64, sulfur is 32, oxygen is 16, hydrogen is 1. So how are we going to do this? Well, we have copper plus sulfur plus 4 times oxygen. Now, this section over here, you can either merge the oxygens together or you can just work it out separately, but you have to add everything together. So 5 multiplied by 2, 10 hydrogens plus 5 more oxygens. Okay, so copper is 64 plus 32 plus 4 times 16. Hydrogen is 1, so plus 10 plus 5 multiplied by 16 again. You could also do just 9 multiplied by 16, because in total there are 5 plus 4 oxygen. So you could just have 9 multiplied by 16. So that's 80. So now we need to add everything all up. So 80 plus 10 plus 64 plus 32 plus 64, and we get 250 grams per mole. So the relative atomic mass, sorry, not the relative atomic mass, the relative molecular mass of hydrated copper sulfate is 250 grams per mole. That means 1 mole of this compound, this hydrated copper sulfate, weighs 250 grams, and because it's 1 mole, it contains 6.02 times 10 to the 23 copper sulfate molecules. Once you deal with 1 mole of anything contains the Avogadro's number of particles, and all those particles will have a certain mass, which is given by its relative molecular mass if it's a compound, or if it's an element, it will be given by its relative atomic mass. This idea that 1 mole of anything will contain a certain number of particles and all those particles have a particular mass is how I tend to do mole conversions with you guys, which is what I'm going to do with you in the coming weeks, converting between moles and mass, converting between moles and particles, converting between particles and mass. Once you understand the idea that if you have 1 mole, that 1 mole always contains this number of particles, and all those particles will have a mass given by the RMM, or if it's an element, given by the RAM.